Hello, ladies and gentlemen. Root Beer here with another math contest, another wonderful contest put out by the University of Waterloo. I'm going to be looking at the Hypatia contest, which is the 11th grade level written solution math contest put out by the University of Waterloo. Specifically, we're going to be looking at the Hypatia from the year 2004. If you'd like a copy of this contest, you can click the link in the description and you can get a copy for yourself to try. You can even pause the video, not proceed in the series, and try the questions out for yourself, which is something I try and encourage. As usual, one question per video, so we're going to be going through question number 1. Okay. So this is a little different than the 2004 papers. 2004 papers had these bonus questions at the end, whereas we're starting to see more of the traditional format, just 4 questions, and they get kind of difficult. The 2003 paper with its bonus questions, the bonus questions were where the difficulty truly lied. They sort of needed, I guess, a year to really work out how hard do we need to make this contest. And doesn't actually say how long this contest is. I can't remember. It's been so long since I had to do one of these. I don't think it's an hour. I think it's 75 minutes you get. But, try it for just an hour. Or, look at a more recent contest. They'll actually tell you how long these contests are. But I always encourage you, if you're going to download it and try it before watching these videos, to try it under real contest conditions. Calculators are allowed, even though it doesn't say it anywhere. So, and each question's worth 10 marks, as I recall from marking these things in past years. So let's get to it with question number 1. It's broken down into 3 parts. We need written solutions for every part. 1a, find all the values of x, which are roots of the equation x squared plus 5x plus 6 equals 0. Okay. So we just need to find the roots, the x's that solve this equation. And there's a couple different ways you can do it. You could factor x squared plus 5x plus 6 equals 0, and you'll get 2 linear factors most likely, and setting each of those equal to 0 will solve for the roots. Or because it's a quadratic, another great way to do this is using the quadratic formula. I think the quadratic formula most people know, so what I'm going to do is I'm going to try and factor it. Okay, so we have x squared plus 5x plus 6. And when you try and factor something in your head, first of all, you have to have sort of a sense that it will factor nicely. Sometimes you can get things that will factor, but in really, really ugly ways, with root 3s and weird fractions in there, and it can be not so nice. One of the advantages of the quadratic formula is that it always produces the answers, no matter how, let's say, ugly the numbers might appear or how difficult or complex they seem. But this is an old, a very good one, an old one that I've seen a number of times. When you try and factor these things, the best thing to do, especially because we've got a leading one here, try and find 2 numbers that multiply to 6 and add to positive 5. So multiply to positive 6 and add to positive 5. And numbers that multiply to positive 6, 2 and 3, or 1 and 6, those are good ones. I'm only considering the positive ones. You sometimes might consider negative 1 and negative 6. But as we're adding to a positive number, I suspect both numbers will be positive. 2 and 3 will work just fine. So we have x plus 2 and x plus 3. A nice little check, if you think you've got the right answer, multiply it out. It's a lot easier to multiply it out than to factor it from its quadratic form. But you can verify that you do have the answer at that point. Okay. So if this is to be true, if x plus 2 times x plus 3 is to be equal to 0 for some values of x, well, if I plug in a number for x, I'll get a number for x plus 2 and another number for x plus 3 and multiply them together to be equal to 0. The only way 2 numbers can multiply together to be equal to 0 is if at least one of them is 0. They could both be 0, but at least one of them has to be 0. Take any 2 non-zero numbers and multiply them together, you're never going to get 0. Okay? This is a nice little mathematical fact there. So either x plus 2 is equal to 0, or x plus 3 is equal to 0. And each of these we can take and solve. So if we bring the 2 over to the other side, we get negative 2. If we bring the 3 over to the other side, we get x is equal to negative 3. So these are our answers for part A, and that didn't take us too long, as we should hopefully expect. Question 1, part A, should be easy no matter what contest you're looking at. Okay, the roots of x squared plus 5x plus 6 equals 0, which we just found, are each increased by 7. Find a quadratic equation that has these new numbers as roots. Okay. So, for B part, well, what are these new roots going to be? So we'll get negative 2 plus 7, that's equal to 5. And we'll also get negative 3 plus 7, and that's equal to 4, because they told us in the question they are each increased by 7. Okay? So these are our new roots. So there's a bunch of different polynomials depending on what constant you multiply by. But we're just going to write it in terms of its roots. So x minus 5 and x minus 4. And now they want a single quadratic, so let's expand this out. X times x is x squared. X times minus 4 is minus 4x. Negative 5 times x is negative 5x. And negative 5 times negative 4 is 20, positive 20. So we can simplify a little bit. And that's a good answer right there. X squared minus 9x plus 20. And if you wanted to, you could double check. Does that have roots 5 and 4? Well, 5 squared is 25, minus 9 times 5, that's negative 45, so that's negative 20 overall, plus another 20. Hey, that's equal to 0. Okay, and we've got one more to go, and that's C part. The roots of, and now they're giving us something a little more complicated, but it's partially factored already, so that's not too bad. The roots of x minus 4 times 3x squared minus x minus 2 equals 0 are each increased by 1. Find an equation that has these new numbers as roots. Okay. So they're each increased by 1. I don't know of a fancy way to do it, especially given this quadratic here. Like I don't know how increasing by 7 will change any quadratic. I don't know how to go from x squared plus 5x plus 6 equals 0 to x squared minus 9x plus 20, other than by taking the roots and adding to by 7. So I think to answer C, what we're going to have to do is first work out each of the roots. 4 will clearly be a root. And then we need to factor this guy right here, this bigger quadratic. And once we have all the roots, there should be 3 of them, increase them by 1. And then do what we did in B part. So really we're doing A and B combined on a cubic, not a quadratic. Okay. So first let's find roots. X minus 4, and then we have 3x squared minus x minus 2. I think that's what it was. 3x squared minus x minus 2. Good. So just like before, if these two things are going to multiply to be equal to 0, we either have x minus 4 is equal to 0, or 3x squared minus x minus 2 is equal to 0. So this first one here, x minus 4 equals 0, that gives us x equals 4. And now we've got a quadratic being set equal to 0. We could try and factor it, but with this 3 in front, I think that would be kind of hard. So I'm going to use the quadratic formula. So it's going to be negative b, that's the middle number here. So negative b, which is 1, plus or minus square root of b squared, so that's negative 1 squared, that's 1, minus 4 times a times c all over 2 times a, that's 6. So we get 1 plus or minus square root of 1. This negative sign and this negative sign will cancel out. We'll get 4 times 3 times 2, that's 24. And 1 plus 24, why, that's 25. So 1 plus or minus square root of 25 all over 6. That's 1 plus or minus 5 all over 6. So that's 1 plus 5 over 6, or 1 minus 5 over 6. And that's 6 over 6, which is 1, or negative 4 over 6, that's negative 2 over 3. Okay. So, we'll get out a little red here. These here are our roots. 4, 1, and negative 2/3. Those are currently the roots. The question's asking us to take these roots, add 1, and then get a brand new function that has those as the roots. All right. So, well, what are our new roots? By the way, usually after I do a quadratic formula type calculation, I like to sub in and make sure do these numbers actually work. You can plug in 1 really quickly and see 3 minus 1 minus 2 is 0. But the minus 2/3, you have to take a moment and pause and think. But it does work. You'll get 4/3 plus 2/3, which is 2, or which is 6/3, which is 2, minus 2 is equal to 0. So our new roots are 4 plus 1, which is equal to 5, 1 plus 1, which is equal to 2, and negative 2/3 plus 1, which is 1/3. New equation, I guess. So x minus 5, that gives us the root of 5. X minus 2, that gives us the root of 2. And x minus 1/3 gives us the root of 1. Now you can do that one and multiply it all out, but you'll get some fractions. Another way to do a root of 1/3 is to say 3x. What's 3 times 1/3? That would be 1 minus 1. So that's another good way of doing it. Okay? And so we want this. So all that's left to do is expand it out. Not too bad. So we'll do the x minus 5 times x minus 2 first. You'll get x squared minus a 5x minus a 2x, and then plus 10. And all that is 3x minus 1. We get our equals 0 there. Now we've got to multiply this out. So x squared times 3x is 3x cubed. Minus 1 times x squared is minus x squared. We could have cleared that up a little bit. Sorry, we do x squared minus 7x plus 10 times 3x minus 1 equals 0. Alright, so once again, 3x cubed minus x squared. Minus 7 times 3, that's minus 21. X times x is x squared. We'll also get plus 7x. And then finally, plus 30x minus 10, all equals 0. We only have one x cubed. Great way to do this is by crossing them off as you go. We've got two x squared two terms with x squared. They combine to give us minus 22x squared. We've got two things with x. I'll keep that minus 10 there. So this should be our answer. 3x cubed minus 22x squared plus 37x minus 10. I like to check, but this should be our answer. I'll check. Well, probably the weirdest one would probably be the 1/3. So let's check. 3 times 1/3 cubed minus 22 times 1/3 squared plus 37 times 1/3 minus 10. One of the 3's and those 3's will cancel out, so we'll get 1 over 9 here minus 22 over 9 plus 37. We'll change that third into a 3 over 9 and then minus 10 becomes minus 90 over 9. So I'll have 1 minus 22 plus 37 times 3. I'll work out what that is in a moment. All over 9. 37 times 3, is that 111? I think that's 111, but I'm going to grab my calculator and double check. It is 111. Hooray. So 1 minus 22 plus 111 minus 90. 111 minus 90, that's going to be 21, or plus 21. And then the 1 and the 21 become 22. So that one worked. And you could also, if you had the time, check 2 and 5. Checking is a great thing to do on these contests, but you should only check once you're done and sort of satisfied with how much you've done. Or if you're stuck on a question and you need something to do to take your mind off that question, go back and check an earlier one. But I would never just decide to check if I hadn't done question 3, but I thought I had a shot maybe to do question 3 if I read it and understood it. But if I read number 4 and said, gee, I don't quite know what they're talking about, let me think about that in the back of my mind for a little while, I might go back and not waste time and check some of the previous stuff to make sure I got that right. Checking isn't required, but it's a great way to make sure that you've done calculations correctly. So right there, I was checking and I made sure that my expansion was correct. And so that cubic I got at the end does in fact answer their question. Find an equation that has these new numbers as roots. That would be it. And if you wanted to, you could put a little therefore statement. Therefore, this one has these numbers as roots. If you want to, that's fine. So that's question number 1. We're going to take a look at question number 2 in the next video. So thanks for watching, and I'll see you next time.